Namaste and a very good morning to all of you. I welcome you to my channel, The Outlier. My name is Mithu, and in today's presentation, we'll be looking at two-way analysis of variance. What exactly is two-way analysis of variance? Firstly, even before I answer the question as to what is two-way analysis of variance, let's take a step back and understand as to what is one-way analysis of variance. One-way analysis of variance is an extension of independent samples t-test. One-way analysis of variance is used to compare three or more groups present in one categorical variable. I repeat, it is used to compare three or more groups present in one categorical variable. What happens if instead of one categorical variable, we have two categorical variables? When we have two categorical variables, we can't use one-way ANOVA. We move on to another form of ANOVA, which is called as two-way analysis of variance. Two-way analysis of variance is used to examine the influence of two different categorical independent variables on one scale variable. I repeat, two-way ANOVA is used to examine the influence of two different categorical independent variables on one scale variable. To see how two-way ANOVA works, let me show you how two-way ANOVA works through a practical example. I'm working on SPSS. Let me access a file which is called as grocery_1 month. To do this, I will choose the file menu, click on recently used data. Right at the top, you see grocery_1 month. As the name itself suggests, this file, grocery file, talks about customers who visit a shop to buy grocery items. You can see people's purchase pattern. The first customer, whose ID is 1, is a male customer. He purchases bi-weekly and he purchases in bulk. And the amount that he has spent is $416. Second customer again is a male, bi-weekly customer. He buys in bulk, and the amount that he has spent so far is $383.24. Third customer buys weekly similar items. The amount that he has spent is $577. So on and so forth. As you can see here, if I had only one categorical variable, I would have used one-way analysis of variance. But there are two categorical variables, namely shopping style and gender. To find out what is the impact of these two categorical independent variables on the scale variable, namely amount of money spent, we will be using the two-way ANOVA. To perform the two-way ANOVA, what we can do is go to Analyze. I will choose the sixth option from the top, which is called as General Linear Model. It offers 4 different options. I will choose the very first option called as Univariate. Once I click on the option of Univariate, a new dialog box pops up. SPSS here is asking me for the dependent variable and the fixed factor. The dependent variable will be the scale variable, namely amount of money spent. When it comes to the fixed factor, I can choose gender as well as shopping style. Now, there are a whole lot of options that are present to the right-hand side top corner. You can specify your own custom model here. I will choose the model tab to do this. Let me click on the model tab. A new dialog box pops up. Here, by default, the full factorial model is used. I will choose the second option, namely build terms. I can choose gender and request for the main effect. I also need the main effect for the variable shopping style. And finally, I need the interaction effect of gender and style. By default, the sum of squares that is used to test the hypothesis is type 3. There are other options as well for sum of squares, like type 1, type 2, type 3, and type 4. I will not disturb the default settings. I'll choose the option continue. I will ignore the option contrast. I would like to see a visualization of what is the impact of each of these variables on the dependent variable. So let me click on the option plots. It is asking me for the horizontal axis and separate lines. Along the horizontal axis, I will choose shopping style, and I would request separate lines with respect to the variable gender. So style along horizontal axis, gender along separate lines. Now I can choose the option add. By default, SPSS produces a line chart. If we want, we can also change this to a bar chart. Let me choose the option continue here. Do I want to perform a post hoc test? Yes, I do want to check for the post hoc test. So let me click on the post hoc test. I want to check for the post hoc test for the variable shopping style. You can see here, there are different options when we assume equal variances. I will choose the option Tukey's test and then say continue. I will be ignoring the EM means method. I don't want to save any new variable. Let me click on the options. Here, I will be requesting for the descriptive statistics. If you want, you can perform the homogeneity test. I will ignore this for time being. We can also evaluate the parameter estimates. I will again ignore this, and I will just choose the descriptive statistics. I'll click on continue. So with this, we are ready to perform two-way analysis of variance. Two-way because, as you can see here, I've got two categorical variables, gender, which is broken down into two groups, namely males and females. I also have the second categorical variable, shopping style, which is broken down into three groups: bi-weekly customers, weekly customers, and people who come often. So let us check what is the impact of these two variables on the amount of money spent by the customer. Let me click on OK. SPSS gives you a lot of output here. In the output window, you see a lot of options. Let me first go to what is called as the profile plot. And as you can see here, this plot is very, very useful to understand what is going on in the data set. As you can see here, in the x-axis, we have the three types of customers: bi-weekly customers who buy in bulk. Second, we have weekly customers who buy similar items. And thirdly, we have customers who come often and buy what's on sale. You see two different lines here. The blue line corresponds to males and the red line corresponds to the females. The y-axis here is the estimated marginal mean of the variable amount of money spent. In the y-axis, we have amount of money spent. So let us interpret this particular chart. What you see here is very, very interesting. It looks like when you compare bi-weekly customers, men spend a bigger amount as compared to women. So male customers who visit the shop bi-weekly outspend female bi-weekly customers. When you look at the weekly customers, the same trend is observed because male weekly customers outspend female weekly customers. When you look at the last category, this is very, very interesting. The two circles are very, very close to each other, which means that when it comes to the often category, males who come often and females who come often spend almost the same amount. They spend close to $400. So this is the output of the line chart, or what is called as the profile plot. Now, let me go to the descriptive statistics. The descriptive statistics, you can see a lot of numbers, but let us not be intimidated. The descriptive statistics is just a reflection of the numbers that we use to construct the profile plot that you saw here. Let's try to understand descriptive statistics. Here you have males, and then it is further broken down into females, and here we have the total. When we look at male bi-weekly customers, weekly customers and often customers, the biggest number is 440, and that corresponds to weekly customers. So it looks like male weekly customers who buy similar items are most profitable as compared to the other customers. We also have other important information like standard deviation and the sample size here. Let's look at the female category. We have three groups here: bi-weekly customers, weekly customers, and often. The largest number that I see here is 405, which means, again, from among the different shopping style, females who visit the shop often and purchase what's on sale seem to be more profitable as compared to the other categories. We also have the description of total. Here, bi-weekly customers, weekly, and often. When we compare, the often customers, people who come often and people who purchase weekly, seem to be very, very close to each other because they spend $404 and $406. If you scroll down, the descriptive statistics and the profiles plot are very, very useful. But if you want to look at statistical evidence, this particular table, that is the test of between subjects effect, becomes very, very useful. As you can see here, we have the corrected model, then we have the intercept, we have the first categorical variable, namely gender, the second categorical variable, shopping style, the third variable, namely the interaction effect between gender and style, is also reported. I have error, total, and the corrected total. I have the type 3 sum of squares being used here. It also gives you the degrees of freedom and the mean square. We also can see the F statistic that is being reported here. The last column is very, very important because this column is the significance level. What we do with the significance level is we take this number and compare it with 0.05. If the significance level is less than 0.05, we can conclude that that particular categorical variable is having an impact on amount of money spent. On the other hand, if the significance level is bigger than 0.05, we can conclude that there is no evidence to suggest that this particular categorical variable is having any effect. Let's inspect this one by one. Let's look at the first categorical variable, gender. And as you scroll to the right side, you can see the significance level corresponding to gender as 0.000. 0.000 is less than 0.05, indicating that we have to reject our null hypothesis and conclude that there is a significant difference in the amount of money spent between the males and the females. So gender is having a very profound impact on the amount of money spent. Let's now look at the second categorical variable, that is shopping style. We can see the significance level being reported here. It is 0.140, which is greater than 0.05. 0.140 is bigger than 0.05, and therefore we fail to reject our null hypothesis and conclude that shopping style is insignificant. The third variable is very, very interesting because here we are looking at the interaction effect between the two variables, namely gender and style. And when you look at the interaction effect and the significance level corresponding to the interaction effect, the value is 0.017, which is again less than 0.05. 0.01 is less than 0.05. Since significance level is less than 0.05, we reject our null hypothesis and conclude that there is a strong interaction effect. So these are some of the important insights that we can pick up from the test of between subject effects. That is, shopping style is insignificant, whereas gender and the interaction of gender with style is very, very important. Let's now scroll down and look at the results of post hoc tests. Here, we are doing a pairwise comparison among the three groups. When we first look at bi-weekly customers, we are comparing it with weekly customers. We are taking a simple mean difference between the amount of money spent between the bi-weekly customers and the weekly customers. And when we take the mean difference, that is negative 26.03, is that significant? When you look at the significance level, it is 0.09, which is greater than 0.05. And since it is greater than 0.05, we fail to reject our null hypothesis, and hence we conclude that there isn't a significant difference between bi-weekly customers and weekly customers. What about bi-weekly and often customers? When we compare these two groups of customers, that is people who visit the shop twice a week and people who come often, there is a difference of $28.24. We have the standard error and the significance level. The significance level is 0.193, which is bigger than 0.05. And since this number is greater than 0.05, we fail to reject our null hypothesis and conclude that there is no significant difference between the bi-weekly customers and customers who come often to the shop. We also see the 95% confidence interval being reported. That is, the lower bound as well as the upper bound for the mean difference is reported here. We can see further subsets being provided. This is the output of Tukey's HSD. We can see there are three groups, the sample size and what is the average spend is being reported. Now this I am going to ignore, and we have already seen the profiles plot, which means that a couple of important insights that I can draw. One is that shopping style is not having an impact. Gender is having an impact. The interaction between gender and shopping style is also very, very important. What we can do now is we can go back to the dialog recall. And as you can see here, the last performed action is univariate. The moment I click on the univariate option, the general linear model univariate option pops up. I can go to the plots, and instead of the line chart, if you want the bar chart, that again can be requested. So let me choose the option bar chart, click on continue, and then say OK. These numbers and descriptive statistics we have already seen, but this is something which is new. Either we can report the descriptive statistics in the form of a line chart or in the form of a bar chart. Very, very interesting. You see the three types of shopping style: bi-weekly, weekly, and often. The blue bar corresponds to males and the red bar corresponds to females. For the first two groups, namely bi-weekly and weekly, the blue bar is longer as compared to the red bar, indicating that the male bi-weekly customers outspend the female bi-weekly customers. I can make the same conclusion about the weekly customers because the male weekly customers outspend the female weekly customers. But when it comes to often customers, whether you're male or a female, by and large, the amount spent is very, very close to each other. So this is how we can perform the two-way ANOVA. When we have two categorical variables, we can compare between the groups. We have looked at post hoc tests. We have looked at the profile plots. We looked at both the line chart as well as the bar chart. Depends upon which chart do you want to show. And we also looked at other important information as far as two-way ANOVA is concerned. With this, I have come to the end of today's presentation. I thank you very much for watching today's presentation. If this video has benefited you, I request you to hit the like button and subscribe to my channel. Thank you very much. Have a great day.